Hello students, I am Dr. Vipin B. Gawande and welcome to video lecture series for engineering graphics. In today's video lecture, we are going to start with unit number 5, Development of Lateral Surfaces. Now, first we understand the meaning of these two words, that is development and the lateral surfaces. Now, development means what? When the surfaces of a solids are laid out on a plane, the figure which is obtained is called as its development. Now the surfaces of a solids that are laid out on a plane. So what is the meaning of this one? So suppose if I take this solid, okay, now this is pentagonal prism, okay, because the base is pentagon, the top face is also pentagon, and these edges are joined by means of the rectangle. So this is pentagonal prisms. Now suppose if I have the sheet of the material, suppose this is the aluminum sheet, and I want now the development of this pentagonal prism. So if I wound this sheet on this pentagonal prism, okay, and when I open this sheet, so what I got here? So here I got here 1 2 3 4 and 5, okay, so that is 5 rectangles. So that 5 rectangles are because of this, the rectangles which are there on the lateral surfaces. So 1 2 3 4 and 5, okay, so these surfaces, okay, rectangular surfaces, these are called as what? These are called as the lateral surfaces. We are not considering this top and bottom pentagon, okay, we are considering only these lateral surfaces, okay, and this is the development of these lateral surfaces, okay. So that means now we get now this development for this pentagonal prism. So if I cut this, okay, so this is the development of lateral surfaces for this pentagonal prisms, okay. Now if I wound this one, okay, so this is 1 2, okay, then this is 3, this is 4 and 5, okay. Now if you join this one like this, if you join this 5, this development, then we get it is similar to these 5 surfaces, okay. So this is called as the development for this pentagonal prisms, okay. Now where we are using this development, so this development is very important in sheet metal work, okay. So through sheet metal work we are constructing some the boilers, then chimneys, okay, then the funnels, okay, etc. Now this sheet metal work is also used in automobile for manufacturing all the components, the outer components of the automobiles, okay, and for this purpose we have to first take the help of this development, okay. Now the development, there are two methods for constructing this development. The first method is called as parallel line development, okay, and the next method is called as the radial line development, okay. Now this radial line, in parallel line development, the solid from which we can the solid which are included in parallel line development, these are cylinder and prisms. And for radial line development, the solid which are there, these are the cone and pyramids, okay. So if there is a problem of cylinder and prisms, then you have to use parallel line development, and if there is a problem of cone and pyramids, we have to use radial line development, okay. So we will see one by one how to construct the development for cylinder, prisms, cone and pyramids, okay. So we'll start with the first method, that is called as the parallel line development, and in this parallel line development we'll start with the first solid, that is the cylinder. Now the cylinder is something like this, okay. So it is having two circles, one is at the top, another at the bottom. Now we have to consider we have to draw its front view and top view. So in top view it looks like a circle, and in front view it looks like a rectangle. Okay, so I have drawn that cylinder here. So it is having two circles, one at the bottom, another at the top. We have given that the cylinder is having base diameter 50 mm. So this diameter is 50, this diameter is also 50, and axis height is equal to 80 mm. So this is the axis height, or this from center, this is the axis height. It is kept on HP. So how to, from the first sentence, first we have to draw the axis. So this is our axis x and y. This denotes the vertical plane, and this below xy it denotes horizontal plane. Okay, so it is given that the cylinder is placed on HP. So we have to start with HP, and in HP first of all we have to draw the true shape. So the true shape of this cylinder is what? It is a circle. So we'll start with the circle of diameter 50 mm, radius 25. Now I am dividing this circle. So divide this circle into 8 parts. Okay, now take the 45-degree angle. Here and this side also. Okay, so the true shape of this cylinder is a circle. Okay, now it is having two circles, so we have to give the nomenclature twice here. Okay, so that means the bottom circle is divided into 8 parts and the top circle is divided into 8 parts. Okay, so for the bottom base circle I am giving the name as 1 2 3 4, and for the top circle I am giving the name A B C D. So for the bottom circle the names are, this is 1 2 3 4 5 6 7 and 8. This is for base circle. Now we have another circle at the top for which I am giving the nomenclature. It is also divided into 8 parts. So I am giving the nomenclature as A, then this is B, then this is C, D, E, F, this is G and H. So you have to be very careful while giving the nomenclature when it is a problem of cylinder. It is having two circles, so you have to give the nomenclature twice. One is for the base circle and another is for the top circle. Okay, so this is the true shape of the circle we have drawn, that is the top view of the circle. Now once the top view is over, now you transfer this projections, or we will draw its now front view. We know that in front view it looks like a rectangle. So transfer its projection up to xy, and so these projections we have to transfer up to xy, and we know that the axis height is given 80 mm. So axis height is 80, so take 80 mm height. So this is axis height 80. Okay, parallel lines here. Here also these all lines are 80 mm. Okay, now these lines also goes up. All projections are of 80 mm. Okay, now in front view also we have to give the nomenclature. So this line, this horizontal line, it denotes the front view of this base circle. It becomes a straight line. Okay, and this line represent the front view of this circle. This is also a straight line. Okay, and then we have drawn this rectangle. Okay, so we have to nomenclature this. So this is the base circle. For base circle the nomenclature is 1. So here it is, this is 1 dash. Okay, so front view is denoted with dash and the top view is denoted with without dash. Now here this is 2 dash and 8 dash. This is 2 dash and 8 dash. This is 3 dash and 7 dash, and 4 and 6. So this is 4 dash and 6 dash, and this is 5 dash. Okay, so 1 to 8 we have denoted, that is the base circle. So this straight line denotes the front view of this circle. Now this horizontal line denotes the front view of this top circle. So it is having the nomenclature ABCD. So this is A dash, then this is B and H, B dash and H dash. This is C and G, so C dash and G dash. This is D and F dash, so D dash and F dash, and E dash. Okay, so this is A to H, and this is 1 to 8. So this horizontal line is for bottom base circle, and this horizontal line is for top circle. Okay, so you have to be very careful while giving the nomenclature. Since it is a cylinder, we have to give the nomenclature twice, because there are two circles. Okay, and the horizontal lines, bottom horizontal line represent bottom base circle, and top horizontal line represent the upper top circle. Okay, now once the front view and top view is drawn, now we'll first construct its basic development. Okay, now since the method which is used for the cylinder is parallel line development, you take the parallel line to the draw the parallel line from to xy, okay, equal to the axis height. Okay, so this is 80 mm. We'll start from here. Okay, so like this. Okay, now what is the length of this development? So if we wrap the paper around this cylinder, and if we open that paper, so the length of that cylinder becomes that equal to how much? So that is become equal to the circumference of the circle, that is equal to pi d. So it is here, it is equal to how much? This is 3.14 into 50. Okay, so that we have to calculate, that much mm we have to take here. Otherwise, if you don't have the calculation here, the simplest method is you take the arc distance from the circle. Okay, if you have the calculator, you take that distance and divide it into 8 parts. Otherwise, the simplest method is to take the arc distance from the circle. Okay, so this distance, arc distance, so this arc distance you have to take. Okay, and then mark here. So this is 1, 2, 3, 4, this is 5, 6, 7 and 8, because we have divided the circles into 8 parts, so we have to take that distance here. Okay, so this arc distance you have to take. Okay, you can take any arc distance here. So this arc distance, that means suppose from 6 to 7 I have taken, so 6 to 7 distance here. So, and since circle is divided into 8 parts, we have to divide this line into 8 divisions. So 1, 2, 3, 4, 5, 6, 7 and 8. Okay, now draw the lines here. So this is the parallel lines or reference. So this is first one, this is 1, then this is 2, 3, this is 4, then this is 5, 6, this one is 7 and 8. Okay, so when we open that paper, so we will get these 8 divisions. Okay, so that distance is equal to how much? So the distance becomes, so this distance is equal to pi d. Okay, so either you take pi d distance and divide it into 8 parts using the line division method, or directly take this arc distance here. Okay, and mark here the 8 divisions. Okay, because circle is divided into 8 parts. Now the next step is this we have drawn according to the first sentence that is given in the problem. We have drawn the circle of base diameter 50, we have drawn the axis height 80, and it is kept on HP. So true shape. So true shape of the cylinder is what? It is circle. So we have start with the circle. Front view is rectangle. We have drawn that one also. Okay, since there are two circle, we have named it twice also. Okay, so first sentence is the nomenclature and the basic development is over. Now it is second sentence is, it is cut by a cutting plane which is inclined at 45 degree. So cutting plane is inclined at 45 with HP. So that comes in front view. Okay, and bisecting the axis. So this condition is given. So bisecting the axis, so we have to take first the midpoint of this the axis. Okay, so take the midpoint of the axis, so it is at 40. Okay, now at that point you draw one small horizontal line. Okay, you draw one small horizontal line, and on that horizontal line now keep the protractor 0, and how much angle we have to take? We have to take 45-degree angle. So 45-degree angle comes here. Okay, and then draw the 45-degree cutting plane. So it comes something like this. Okay, so cutting plane is something like this. Now this angle is how much? This is 45-degree angle, and it is bisecting the axis. So this is 40, this is 40, and this is called as AIP. Okay, this is called as AIP, that is auxiliary inclined plane. Okay, auxiliary inclined plane, and the plane is inclined with HP, so that plane comes in VP, that means front view. Okay, so when the plane is inclined with HP, so it cuts the front view. For all the problems, the when the cutting plane is given, so in our syllabus the cutting plane cuts our front view only. That means all the problems are related with AIP. Okay, so whenever the cutting plane is given, you have to cut front view only and not the top view. Okay, for all the problems. Okay, so here this is inclined at 45 degree, so and bisecting the axis. So two conditions are given. First is the angle, and then the axis, bisecting the axis. So first bisect the axis, draw one horizontal line there, keep your protractor 0 here. Okay, and then take 45-degree angle, mark that point, and then draw the axis, the cutting plane. Okay, now we have drawn the cutting plane. That means now this part get removed. Okay, the top part of the cylinder get removed, and when this cutting plane cuts our cylinder, now how much part of the development we get here? Okay, or what type of development we get here? Now the method is very simple. Now just see how to mark the first of all we now will mark the intersecting point. Now when our this cutting plane intersect our cylinder, so we'll get this intersecting point. Now suppose this red plane is our cutting plane, and suppose this is our edge. So when it intersect our edge, so we'll get here intersecting point. So for if one edge is there, so one intersecting point. If there are two edges, we will mark the two intersecting point. So we'll start from this direction. Okay, now while going from the left to right, at one time you take one edge only. So, okay, so we'll first take this point. Okay, so here it is only one edge. Okay, you either take this nomenclature or this nomenclature. So here this is one dash, that means it is here it is only one point is there. So I am marking this, suppose this as a P1. Now here there is an intersection. So now here how many edges are there? We have two edges, that is 2B and 8H. So while going in left to right, I am taking only one first, so I am taking 2. Okay, so for 2 I am marking here P2. 8 is left there, so it will take while coming back, because the condition is what? You take the one intersection at one time. So, okay, now here again, here there are two edges, 3C dash and 7G dash. So for you take only one, that is 3 dash. So for 3 dash it is P3. 7 will take while coming back. Now here it is 4D dash and 6F dash. So for will take only 4. So it is P4. Okay, 6 is left, will take it while coming back. Now here this is 5E, it is only 1. Okay, so this is 5 only. So we'll mark here P5. Okay, now while going from left to right, we have marked the points. Now come back. So while coming back, now 6 is left. So this is P4 and P6. Now here this is 7 is left, so P3 and P7. Now here 8 is left, so P2 and P8. Now 1 is there, we already marked. That means here it is only one edge, so one intersection. Here are two edges, so here there are two intersection. Here there are two edges, so we have marked here two intersection. Here there are two edges, 4 and 6, so we have marked here 4 and 6. Here it is only one edge, so that is one intersection. So this is very important. Okay, one, if the cutting plane it intersect one edge, one intersection. If there are two edges, we get two intersection. Okay, that is the simple method. Now we have to transfer this intersection on the respective edges. So for that we'll give the nomenclature. Now since this nomenclature is 1, okay, so this is 1 dash, then this is 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash. Okay, 1 to 8 dash is over. Now again when we wrap that one, so the again it joins with 1. So last one is also again 1. So because this 1 and 1 will join together. Okay, so that means this is 1 and this is also 1. So when we join it, so it comes like this. Okay, so this is 1, then this is A dash, this is B dash, C dash, D, E, F, G, H. So A to H, and then again last one is again A. So first and last is same, A dash, 1 dash, 1 dash. Okay, now transfer this intersecting point. Now take the reference of the horizontal axis. Okay, now P1, is on 1 dash. Okay, it is on 1 dash. Okay, so P1 comes up to 1 dash. Okay, so this intersection comes here. Okay, so this intersection comes here, so this is P1, it is on 1, so here also this is 1, so this is 1. Okay, P1 is on 1 dash, 1 dash and 1 dash, or it is on A dash or A dash. You take either this nomenclature or this nomenclature. Now P2 is on 2. Now P2 it comes on 2 and 8. Okay, so this P2 it comes on 2 dash, so this is P2, and this is P8 is on 8, so this is on 8, so this is P8. Okay, so horizontal lines from intersections. Okay, now the third one is from P3 and P3 and P7. P3 is on 3 dash or C dash, so this is P3, it is on 7, so this is P7. Okay, P3 is on P3 dash, P7 is on 7 dash, so this is on 7 dash. Okay, now from the 4 and 6. Okay, so P4 is on 4 dash, so this is P4, and P6 on 6 dash, so this is P6. And now the last one, that is P5. So P5 is on 5 dash, so this is P5. Okay, this is P5. Okay, so now what we have done, we have transferred this intersection on the respective edges. So P1 is on 1 dash. Okay, P1 is on 1 dash here and here. Okay, P2 is on 2 dash and 2 dash B dash, so this is on 2 dash and B dash. P8 is on 8 and 8 dash and H dash, so this is 8 dash and H dash. P3 is on 3 dash and C dash, 3 dash and C dash, and P7 is on 7 G dash, 7 G dash, so P7 is here. P4 is on 4 dash D dash, 4 dash and D dash, P4, 6 dash and F dash, P6, and P5 is on 5 dash E dash, 5 dash and E dash. Okay, now we have got the points now. Okay, P1, P2, P3, P5, P6, P7 and P8 and P1. Now since this is a cylinder, when we cut the cylinder, the development it comes in the form of curve. So this you have to remember. So whenever you cut this cylinder, the development it comes in the form of curve. Okay, so now join this one. Okay, so it comes in the form of the curve. So use now the French curves. So I don't have the French curve, so I'm joining it with the free hands. So it comes something like this. So don't join it with the scale, because when we cut the cylinder, the development it comes in the form of what? The curve. Okay, so something like this. Okay, so this is the development. Okay, so this part is the development of the cylinder when we cut the cylinder by using this cutting plane. This part, okay, this part get removed because of this cutting plane. Okay, so we have removed this part, we are left with only this part. Okay, so in the examination you have to make this part dark. Okay, so this part is dark and you have to keep this part faint because this part get removed. Okay, circle is also dark and only this much below the cutting plane, whatever the part of the cylinder is there, that part is only dark and this part is what, it is a faint. Why? Because this part get removed because of this cutting plane. And in development also only this much blue part is dark, this rest of the construction is faint. Okay, so this is the development of the cylinder. Okay, I hope you are understand. The steps are very simple. First construct the front view and top view of that particular solid. So here we have cylinders, we have drawn front view and top view of that cylinder. After drawing that cylinder, we have constructed the basic development for the cylinder. We have taken the length pi d. Okay, you divide that into 8 parts, or you take arc distance from the circle and divide it into 8 parts because circle is divided into 8 parts. Okay, after that, now the second condition is the cutting plane. So we have taken cutting plane, it always cuts the front view, so it bisect the axis. So we have taken the midpoint of the axis. I have taken 45-degree angle line, so that is our cutting plane. Now while marking the intersection, if one edge is there, you mark one intersection. If there are two edges, you mark there two intersection. Okay, and then we have transferred that intersection on respective edges and we have drawn the development. Okay, so we'll come the same steps you have to follow for the rest of the problems also. If you understand this problem, all the remaining problems are similar to this problem only. Okay, so thank you very much.